Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, I would like to explain about the equivalence of regular grammar. So till now we have seen what is meant by regular grammar and how many types of regular grammar we have and where is this grammar comes from and which type of languages we are using for this regular grammar, and how to form a regular grammar to a finite automata and how to convert a finite automata to a regular grammar. We already discussed all these topics in the previous videos, and now we will discuss about the equivalence. So equivalence is nothing but we have to convert from one regular non-linear regular to another regular linear grammars. So here we will convert the right linear regular grammar to left linear grammar. How, we will see. So there is a procedure to construct a right linear grammar. So what are the steps involved in this one? So before that, regular grammar is divided into two types. So what is those? So here left linear grammar and right linear grammar. So these are the two types. So what is the equivalence? In the sense, we have to convert right linear grammar to left linear grammar and left to right. We can convert it to a both. So that is the equivalence between the regular grammar. So here in the first procedure, the construction of right linear grammar. So here what is the first step what we have to do for the construction of right linear grammar, left linear grammar? So here draw a transition diagram for a given regular grammar. Suppose how to write this transition diagram? That is nothing but we have to find the finite automata for the given regular grammar. So how to convert this given regular grammar to a finite automata we have discussed in the previous video, and based on that procedure we have to convert that regular grammar into a finite automata. So that is nothing but in the form of transition diagram, and interchange the position of initial and final state. So here we have to we want to convert that regular grammar into a left linear grammar. First step we have to do, we have to convert the regular grammar into finite automata, and after that we have to convert whenever we have the finite automata. In that finite automata, we already know that finite automata is having initial state and final state. So final state is represented with the double circle, and initial state, which is Q naught, and QF is a final state. So we have to change these interpositions. So here, so final state is here and the starting state is here. We have to interchange the position of initial and final states in the step 2. And step 3, we have to reverse the edges. So whenever reversing the edges, in the sense, here suppose the Q naught, it is having this side. So QF. So we have to, in the third step, we have to reverse these edges like this. So when it is moving from Q naught to QF, so we have to reverse the edges, in the sense, so we have to move that input symbol to the QF to Q naught. So that is how we are reversing the edges in the finite automata. And next, write the production rules. After reversing all the edges in this finite automata, we have to write the production rules. So how to write the production rules from the given finite automata we already discussed. So here let me explain in brief. So suppose here this is the transition function. So for this transition function, how to write this one? So QF comma, let's take 0 as an input. It is reaching the state Q naught. So this is the one transition function which is involved in this transition diagram. So in this, by this transition function, we will write this production rule. So here, what is the production rules? In the sense, QF tends to 0 with the 0 input and Q naught. So this is how we are writing the transition function to a production rules. So there are two cases. In case of it is a only terminal symbol. So in case of only, so in the transition diagram, when it is the input for the given input, it is reaching the final state, we have to write the two productions. So along with this, we have to write suppose it is a final state. So here QF tends to 0. We have to write the two productions for the final state. So transition, which are the state involved in the final state. So we have to write the two production rules. So these already discussed in the previous videos with the conversion from a finite automata to a regular grammar. In that video, we discussed about this how to form a production rules from the given transition functions. And here we already done the writing the production rules and adjust non-terminal to the left side. So here we are dealing with the left linear grammar. So the left linear grammar, suppose I will write the example of, so S tends to AB, comma BA, BB and A. So this is the reproduction rule. So whenever we want to write that to a left linear grammar, we have to, the terminal, non-terminal should be in the left side and the terminal should be in the right side. So this is how we, after all the production rules we have written from the production transition function, we have to write this according to this and B, comma N. So this is how we converted this production fourth step to fifth step. So fifth step is now adjust the non-terminal to left side. So non-terminals we are adjusting to the left side. So this is how we are taking the procedure of to convert the left linear to convert the regular grammar into a left linear grammar. And so here we will discuss more this with the example how to convert that given regular grammar into a left linear grammar. So what is the example? So here I am writing the production rules of regular grammar. So S tends to B and B tends to B C and B tends to A B and C tends to A and B tends to B. So this is a given regular grammar and how to, in the first step of converting the given regular grammar into a left linear grammar. So here the left linear grammar, the first step contains the transition of this production rules to a transition diagram. So how in the first step, so here this is the regular grammar. So regular grammar, we have to convert that to a left linear grammar. So here the first step contains, so we have to write the production rules to a transition diagram. And how to convert these production rules to a transition diagram, we already discussed in the previous video. So I am writing this production rules to a transition diagram. And here before constructing a transition diagram, so what is the finite automata requirement? So we need to find out the phi tuple for that one. So what is the phi tuple of this transition function? In the sense, the Q is equal to, it is a finite set of states, and when comparing with the regular grammar, that is equal to V. So what are the states involved in this one? In the sense, what are the non-terminals which are all in the production rules are all called the non-terminals, and the non-terminals are represented as a finite set of states. So here S comma B comma C. And here we have to observe that the production rules which are having the only terminal which contains, it represents the final state. So whenever we are giving that input symbol, it is reaching the final state. So here we have the two non-terminal symbols. So it represents there is a final state which belongs to this one. So here I am writing the D as a final state. So and here after that we find out the Q value and we have to find the sigma value. What is the sigma in the sense? So what is that equivalent to the regular grammar? So sigma is nothing but terminals. So which are involved in this production rules. So A comma B is the terminals. So which are equivalent to the input symbols. And after that what initial state. So initial state is S, and that is equivalent to the Q naught. And next one, production rules, though that is nothing but which are transition functions. And next final state is D. So here the final state is D. So these are the requirements for the construction of a transition diagram. So with this we already have the values, and with this we will construct a transition diagram. So here the first step is to construct a transition diagram. We need an initial state. So initial state is S, and after that state B is there, and we will write the other states also. And D is the final state, so we will represent it as a double circle. And this is the first step. So first step is we just draw the transition diagram. And next, how to write the transition diagram in the sense, we have based on the production rules, we will convert to a transition function. So here S tends to B is there. So how to convert this to a transition function in the sense, so S tends to, so transition of S with the input symbol B, it is going to B. So here it is reaching with the B input symbol, it is reaching this one. And next production rule, from B state, whenever we are giving the B as an input symbol, it is reaching the state C. And from the state B, whenever you are giving the A as an input symbol, it is reaching the state B. And from C state, whenever we are giving the A input symbol, it is reaching the D state. And from B, whenever we are giving the B state, B as an input symbol, it is reaching the final state. And this is the transition function, transition diagram, which we converted from the reproduction rules. And second step, what we have to do, we have to interchange the positions of initial and final state. So how to interchange the positions in the sense? So here initial is S and final is D. So here we will write the D and we will write here S. So we just interchange the positions of the initial and final state. And next step, remaining states same as this. And this is the second step, right? We will interchange the positions of initial and final states. And third step, what we have to do, we have to reverse the edges. So reverse the edges of the first transition diagram. So after writing this, here we have final state and B as an next state and C and next S. And here we are going to reverse the edges. So that is nothing but whenever it is having the B as an input symbol, it is going. And here also from B state, and a self loop is as it is. And here B, and next whenever it is having A input symbol. So this is how we reverse the edges of the first transition diagram. And after that, fourth step, what we have to do, we have to write the production rules for this one. So production rules for the reversing all the edges and interchange the position. And how to write the production rules for the given transition diagram in the sense, we already discussed this in the previous videos, how to convert a finite automata to a regular grammar. And here we will write with the starting state S, and whenever we are giving the A as an input symbol, it is reaching the state C. And here from S state, B as an input symbol, it is reaching B. And from S, so already we have A, B input symbols, and we have to take the B state, and it is reaching A as an input symbol, it is reaching the state B. And whenever we are giving the B as an input symbol from the state B, it is reaching the D state. And also we have to write the terminal symbol also. Why? Because it is reaching from B state with the input symbol B, it is reaching the final state. So it is reaching the final state, we have to write along with the terminal symbol. And from the C state, so B has an input symbol, it is reaching the B. And D state, there is no transition functions from the D state. So this is how we converted this transition diagram to a regular grammar. So, and in this one, there is a how to represent the left linear grammar in the sense with the right side of the transition diagram, right side of the production rules, there is a non-terminals like this. So like this we have to represent. So here it is a all or in right side. So how to change this in the sense? We will just change the positions of the terminal and non-terminals in the right hand side. So only right hand side we have to change. And C, A, S tends to B, B, and B tends to B, A, and B tends to D, B, input B, and C tends to B, B. So this is how we converted the left linear grammar. So given regular grammar to left linear grammar. So here this is the procedure how to convert a given regular grammar to a left linear grammar. And we will also more discuss about with the another example. We will take one more example. So example 2. So A naught, we are taking the example 2 with the state names A naught, A1, B, A1, and A1 tends to A, and A1 tends to B, A naught. So here also one terminal is there, only one terminal. So what are the requirements? So here how to convert that to a left linear grammar in the sense, first step we have to do, we have to convert this production rules to a finite automata. So finite automata requirements Q, sigma, and initial state I. So transition functions and final state. So here Q is equal to, so what is the finite, what are the states, non-terminal symbols which are equivalent to V. So non-terminals are A naught, A1, and here there is a only single terminals. So single terminal in the sense we require a one new state that is called A2. So that is a nothing but a final state. And sigma, which is having, what is the sigma? So this is the Q, and sigma is nothing but input symbols, there is nothing but terminal. So A comma B, and I initial state is nothing but we are starting with the production rules with the A naught. So A naught is the starting state, and F is the what we have taken a new state A2, and production rules we have to write. So from the transition functions we have write from the production rules. So and here the first step is to convert a transition diagram. So transition diagram, for this one what we require? So we require the state, starting state and final state. So let me write A1, A2, A0, A1, A2. So these states are there, and in that one A0 is the initial state and A2 is the final state. So from A0, A as an input symbol, it is reaching the A1, and from A1, B as an input symbol, it is reaching the self loop, so B, and from A1, A as an input symbol, it is reaching the state A2, and from A1, whenever we are giving the B as an input symbol, it is reaching the A0. So this is the transition diagram which we are converted from the given regular grammar to a transition diagram. And second step we have to do, we have to interchange the position. So here interchanging the position in the sense final state, first final state. So A2 is the final state. So here writing, and A1 as it is, and A0 is the start state. And third step we have to do, we have to reverse all the edges. So here the reversing all the edges in the sense, first A2, so the double circle A1 and A0, so initial state, and from here we will write A as an input symbol, it is going to here, and here, so here, sorry, so from reversing the edges in the sense, so self loop is same itself, and here A as an input symbol and B as an input symbol. So that is we reversed the edges of the states. And next step, fourth step, what we have to do, we have to convert that to a production rule. So here the starting state is A0. So A0 to A as an input symbol, it is reaching the A1. And from A1, so there is no other inputs to the A0. So from A1, B as an input symbol, it is reaching the A1, and we will take A1, A as an input symbol, it is reaching A2, as well as we have to write the A input symbol. Why? Because it is a final state. And from A2, so there is no input. So there is a transition function from B as an input symbol, it is reaching the A1. So this is how we converted a transition diagram to a production rule. So and here one more thing we have to do, we have to write that to a left linear grammar. And here we will just interchange the positions of terminals and non-terminals in the right hand side. So here A1 A and A1 B and A1 A2 A with the input symbol A, and from A to A1 B. So this is the left linear grammar where we have converted from the given regular grammar. And next step, we have discussed about the conversion of any regular grammar to a left linear grammar, and how to convert that left linear grammar to right linear grammar. There is an equivalency between we convert from one regular grammar to another regular grammar. So here what is the conversion of regular left linear grammar to right linear grammar? So we have to repeat the same steps, how to construct a transition, how to construct a left linear grammar from the given regular grammar. Here also only the thing is we are just leaving that fifth step. So fifth step is we are writing the interchange the positions of position adjustment. So position adjustment is not applicable here. Why? Because it's already there in the right linear grammar. So here this fifth step is not there. The remaining all are same. So first step is what we have to do, draw a transition diagram, and whenever they are giving the left linear grammar, we will convert that to a transition diagram first. After that we have to change the interpositions of initial and final state, and we have to reverse the edges and write the production rules. So these are the steps involved in the construction of left linear grammar to right linear grammar. So we will discuss more about with this example. So here I am taking the example. So S tends to AS, SB, AB, and example 1, and A tends to AS, AB, A, and here one more production, B tends to B, B, and epsilon. So here the production rules which are also contains the epsilon symbol. And here how to first step is what we have to do. So here with this production rules we can say that these are all left linear grammar. So why? Because the non-terminals are all in the left hand side. So here all the non-terminal symbols are left hand side. With this we can say that it is a left linear grammar. And now we will convert that to a right linear grammar. Right linear grammar. And the first step is what we have to do. We have to write the production rules. We have to write the transition requirements. So Q, sigma and delta and initial and final states. So what are the states we have in this one? That is nothing but V. So those are all the non-terminals which are involved in this one. So what are the non-terminals here? S, A, B. And sigma is nothing but input symbols. What is the input symbol? A, B are the input symbol, and transition functions we will write. And I is equal to, we are starting with the production rule S, that is nothing but initial state and the final state. So we have to find the final state. So there are no final states here, and we will write the transition diagram for this one. First write the transition diagram. So first step is S and A comma B. So here we will write from S tends to SA. So SA as an input symbol, it is reaching the self state A, and from the S tends to B also, we will get B, and from S tends to B as an input symbol, it is reaching the state A. And next step, so from A state, it is reaching the A as an input symbol, it is reaching the self state, and A as an input symbol, it is reaching the B state also. And here, so whenever there is a epsilon symbol is there, we will write this as a final state. And here, and from the B state, B as an input symbol, it is reaching the self state and sigma. And here, we will write this first step we have done. So that is the conversion of production rules to the finite automata. And now we will, in the second step, what we have to do, we have to interchange the positions of initial and final state. So initial state is S, we will write here, and here this is the initial state, and B as a final state, and here. So, and after that we will write the third step is we have to reverse the edges of states. So what are the states we have? So reversing the edges in the sense, so here from self state is as usual A comma B, and here B from A it is coming to, and here self states are all same, and here we will write A and this B. And fourth step, what we have to do, we have to convert that transition diagram to a production rules. So how to write the production rules for this given diagram? So here we will write starts from state S. Why? Because starting initial state is the production rules initial state, and here S tends to B, S, B, S, and here we have to write the one more state from A also it is there. So S tends to A, it is reaching the state A, and from A state, whenever we are giving A as an input symbol, it is reaching the self loop, so A state. And from A state, whenever we are giving the B as an input symbol, it is reaching the final state. So that is how to represent a final state. We have to write like this. And here from B state, whenever we are giving the A as an input symbol, it is reaching the state B, as well as we have to write the terminal symbol also. From state B, B as an input symbol, it is reaching the B, and we have to write the B. And these are all we have to simplify. So simplifying, so S tends to B, S, A, and A tends to A, and B, comma B, and B tends to AB, and B, and A, comma AB. So this is the right linear grammar. So we converted the given regular left linear grammar to right linear grammar. So this is about the equivalency of left linear grammar and right linear grammar. We can convert that left linear to right linear, or right linear to left linear grammar. So this is about the equivalency of regular grammar, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.